endothermic reactions today. All right, so first of all, exothermic. So exo, that prefix is outside. So it's an easy way to remember. Thermic is temperature, so outside temperature. So at the end of an exothermic reaction, we are releasing heat and energy into the environment. So things like fireworks. So we think about the heat and energy released in firework reactions, and this is released as heat, it's released as light, and even sound. So we wouldn't, that's how fireworks works. So we've got a graph here. Up here, guys, is the amount of energy. So you can see reactants, we start off with a lot of energy and then it gets all released and the products end up with less energy. So that's exothermic. So we are releasing energy or heat into the environment. All right, so endothermic, endo is inside. Thermic is temperature. So we are requiring energy or heat to actually start our reaction. So if we think of photosynthesis, so think about plants needing to eat and produce the sugars and everything. To actually start photosynthesis, we need energy, and we need energy from the sun. So to actually start this reaction, we need that energy to be able to move forward. So it makes the environment overall cooler. So as you start, you can see the graph, it's opposite to our exothermic. So we start off with really low amount of energy in the reactants, and then we require all of this energy, and we end up with the products having way more energy than the reactants did. Okay, so that's a little bit of an introduction. We will be going over exo and endothermic reactions as we go on in the lessons, but that's just a brief one. So things to take away: exo, outside, so it releases a lot of energy when the reaction occurs. So like fireworks, in the case of light, heat, and sound. Endothermic, it requires energy and heat. So think photosynthesis, it has that energy from the sun to actually be able to convert that carbon dioxide and water into sugar and oxygen.
Alrighty guys, so now what we're going to do, we're actually going to do an experiment so you guys can see what an endothermic and an exothermic reaction look like. So we're going to start off nice and safe. We have no flames, so we can have our hair down. Just going to make sure we can't get the chemicals in it. We have our glasses on because we are using an acid today, and then we're also going to put our gloves on to protect our skin because we all know that acids are corrosive and we don't want that to hurt our lovely skin cells. So we'll see you in a second.
Hi guys, back to it. So we are going to be putting this up on style, so you don't need to copy out the table. You'll be filling that in on the style lesson. So we're going to be doing two experiments today. First experiment will be with hydrochloric acid and magnesium, and the second experiment will be putting vinegar and bicarb soda together. So the whole point of today is to see which reaction is an exothermic reaction and which reaction is an endothermic reaction. So we're looking at the temperatures. Do they increase or do they decrease in the experiment? So with an exothermic, it releases energy. So do we think that will increase or decrease the temperature? Hopefully you will have answered increase over time. Endothermic, remember, requires energy. So if it requires energy, it's making its environment colder over time because it's taking it all in. So hopefully over the experiment, you'll be saying that the temperature should be decreasing.
So if you guys are on style at the moment, you'll see little sections that you need to fill out after you've kind of watched this video. So the first one you're going to fill out is nice and simple, the title. What are you going to call your simple report? So give us a name. More than 2 words would be nice, please. Okay? So then after that, you'll see a lovely little section which will say aim. The aim of the experiment, what do you guys think it is? You can pause it and have a guess. We're probably just going to say it anyway, but you never know. But the aim of your experiment is to obviously determine out of these 2 tests here, which one is going to be the exothermic and which one's going to be the endothermic. So that is our aim. You then have got your hypothesis. Now we're not going to probably write a proper one, but we just want you guys to take a guess. Which one do you think is going to be which? Okay? So that's all you need to fill out for that section. And what we're going to do now is we're going to go through the experiment itself. Now, you do not need to write out the materials or the method or anything like that. We're not going to be that cruel to you guys. So what we have in front of us that you can't see until we hold it up is all the equipment that we will be using. So we'll start with this one.
Measuring cylinder.
Yeah, you guys all know what that is.
We've got a thermometer to be able to check our temperatures.
We have got test tubes to place our substances in.
We've got tweezers and a teaspoon.
We have got some white vinegar.
We've got some hydrochloric acid.
We've got some bicarbonate of soda.
And magnesium ribbon.
And then we've got some lovely beakers.
Beakers.
All right, so first experiment we are going to do today is the hydrochloric acid and the magnesium.
So we need to put 20 mils of hydrochloric acid into a test tube. So I've got my measuring cylinder. I am going to pop 20 mils of hydrochloric acid in. All right, so 20 mils of hydrochloric acid is going to go into our test tube. I know. Okay.
Alright, so now what we're going to do is that we are going to measure the temperature of our hydrochloric acid before the reaction. So, let it sit in there, slowly moving, not a lot. Alright, so remember we want to get down to eye level whenever we're doing measurements. It's still going down, so we're just going to let that sit in there for maybe a second or two.
I don't have to stand here. So we're going to test the temperature before we add any magnesium and then after to see if it increased or decreased.
Alright, so let's see, has it moved? No, okay, so it stayed at that temperature. So our hydrochloric acid before is at 18 degrees.
18 degrees Celsius. So now what we're going to do is we are going to add a piece of magnesium ribbon, which is literally just a strip of magnesium, and we are going to swirl the test tube around.
So I'm going to try and, well, maybe we'll hold this a bit closer to the camera so you guys can get a proper look at it. Alright. So we have placed our magnesium ribbon. So you can see right up there, there is the ribbon, and we can see a lot of bubbles, okay? There are a lot of bubbles coming off that ribbon right now. So that metal is reacting with the acid, okay? So what we're gonna do, gonna cover that with my thumb, gonna give it a swish, and we're gonna wait for this reaction to finish. So,
and then once that has finished, we are going to record the temperature again to see if it has increased or decreased from the beginning.
What we're going to do, we're going to let that reaction occur, and we are just going to sit this in there.
Right, back to it, guys. So, checking the temperature now, it is at 25 degrees. Alright, so we went from 18 to 25 degrees. So, has the temperature increased or decreased? Pause this video now if you need time to think.
Another thing, guys, if you actually touch this, it is warm to the touch, okay?
So, the temperature has increased over time. So, what do we think? Whether it is exo or endothermic. So, we're not going to say, all you need to think about, exothermic releases energy into the environment as heat, and endothermic requires the energy and heat. So, think about whether the environment will be hotter or cooler in those instances.
So, we might just include in here by how much it has increased by. So, it has increased by 7 degrees. Cool, perfect. So an increase of 7. Alright, so now we're going to go on to our second experiment, the vinegar and bicarb soda.
Okay, so we are going to put 20 mils of vinegar into a test tube. So again, we get our measuring cylinder out and we measure 20 mils.
Now, why do you guys think they are both 20 mils? So why are we using 20 mils of hydrochloric acid and also 20 mils of vinegar? What variable would that be covering? Have a think about it. Beautiful.
All right, do you want to add the bicarb?
Well, what do we need to do first?
Well, what do we, yes. Miss Inu's forgotten. We need to make sure we test the temperature before we add in our bicarb soda.
Now, a lot of these liquids are close to room temperature, so we would probably estimate that it should be around the same at 18, but we will sit and wait and find out. We will fast forward this for you guys so you don't have to wait awkwardly with us. It's at 17 degrees, so 1 degree less than our hydrochloric acid. Beautiful.
Okay.
So we're close to that estimation. But that's why we check and we measure.
Did you want to put in a teaspoon of bicarb?
Yes, so I'm sure you guys know what happens with bicarb and vinegar. I am slightly worried at how high the vinegar is to this one. So we're going to just put a lovely little beaker below it just in case. So we're going to do a teaspoon, was it a teaspoon, half a teaspoon?
Teaspoon.
Teaspoon, my goodness. All right, so we've got our teaspoon of bicarb. So let's see if I can get this all in. Oh, we need the thermometer in there. Why do we do this? This reaction is very quick, a lot quicker than our acid and metal. So we're going to chuck that in there to make sure we don't get a misread. Oh, let's just go. Alrighty. So we've got our reaction occurring.
So already, guys, we can see lots of bubbles. Maybe I'll take it up.
Yeah.
So there's lots of bubbles. It's starting to overflow. And the temperature is going down, down, down. It's already at 12 degrees.
Wow, there we go. It's really going. All right, I think the reaction stopped. Okay.
I took it out so it will be warmer actually.
Yeah. Yeah, that's okay. So we're actually now sitting at about 13 degrees.
Okay.
Which is still a decrease.
So we had 17 degrees, it went down to 13 degrees. So it has decreased. By 5 degrees. All right, do we think that is exo or endo?
4 degrees. 4 degrees.
All right, so you need to put in whether it is exo or endo. We hope you enjoyed the video.
Yeah, good luck. Finish the rest of the questions. Once you're done, press submit. If you finish early, you're free to enjoy the rest of your day. Hopefully we'll get to see you guys back at school soon. We miss you.
Miss you, bye.